All right, we are back, and today we're going to kind of continue our conversation on writing our GraphQL level store. And last time, if you recall, we got it working to the point where we can query for level and have those queries be outside of the database, but we did not do the rest of the key scenario, which is to create the level. So that's going to be the next step for us here. So, oh wait, and now I notice we have an error here, but are we even running the server? Let's first see what's going on here. We'll take a peek. Fire it up. We always want to make sure we're in a working state. Who knows what could have happened in the days since we last touched this. Whoa, it's some loud dogs. All right, so with that in mind, let's refresh, make sure we're connected, and see where we're at. And we're getting an error here. This is kind of interesting. Sheep is not defined. Well, seems like a good time to figure out what's wrong with that. So let's go to our resolvers here and take a look. So when we already had our get sheep for level, it should be working. Let's query it. All right, so if we look here, we've stopped at the level. It's being passed in here. This looks correct. Data values. Looks very nice. We have our test level with our ID. And we're trying to get level.id. And what we can see here is what we're passing for level is not actually the right thing. We actually want the data object on this. So what this also probably means is that we're not returning the level object correctly either. So let's go stop this run. First, we'll just let this thing error out. And go back to our query here. And let's take a look without these subqueries. So we can see it's fetching this, but apparently not the lower level things. Okay, so let's see what we're saying here when we do this get levels. Again, we'll go run this and see what we get at this breakpoint. So at this point, we do get our two levels correctly here. So it's a little bit mysterious that we're passing these in, but we're not getting our data values. So let's just go ahead and edit that now. So in our level here, we need to get the data values. Let's try that out. All right. Put in our sheep query again. And we can see what we got here. Get rid of that breakpoint and go over here. And our level is a model, looks like, and we have our data values. And we have this. So the interesting thing here is we're not really fetching the property that we would think we would be getting here, apparently. So if I go to level, I get that. I can do level.dataValues. And get that. So I could do level.dataValues.id and get the ID. But we should be able to do level.id, which it isn't even letting us complete here. Oh, there you go. All right, so level.id seems to be working. That part looks good. Let's go ahead and step into this bad boy here. So we were going to go to the definition of this one and see what exactly is not working here. It definitely seems to be feeling like ID is not defined, which is kind of odd. Everything looks pretty good. This is the call to the second one. But this call does not seem to actually be getting through. So a bit strange there. Field resolve sheep should be okay. So what I've done here is we just kind of break the code down, just something that we often try to do when things are not working the way we think they should, just so give us a better sense of what's happening. So let's run it with this and see what we come up with, see if that works any better. That looks good. Have our ID of 1. We're going to fetch the sheep here. Now we can see we're going to get sheep for level. So here we can see that when we're returning from this function here. So this is basically because we're using these asynchronous methods. So now it's going to return the sheep, which is in fact undefined. So let's stop this, and we can see here that we're binding this to objects, but we're returning sheep. So this is one of the common cases that we see when we do a lot of cut and pasting of code. We clean up some and we miss some cases. It's a good time to take a look and see if we did that anywhere else. Looks okay. Other places. Let's go run it again. And now we're fetching our sheep correctly. Good. Well, a little impromptu debugging lesson. Never hurt anybody. Now, what we really want to talk about, though, is how do we make a level? Well, in GraphQL, remember we define queries. And what a query is it returns data. It's kind of like doing a get in HTTP or something. One of the basic rules of GraphQL is that queries do not modify their data. And even though there's nothing in the code that's stopping them from doing that, that convention allows us to do things like, assume that, if I don't have to check to see if anything else changed just because I did a query. If we want to change data, we use a different data structure called a mutation. And those work pretty much the same way, where I have mutations in my schema and I just define them of what they look like. And for a mutation, I basically would give it the name of the mutation. So I have a mutation like create level, and the parameters that it takes. So this is where it gets interesting, because what do we need to create a level? Well, basically, it's just a level object. I give it all the data for a level, and I want it to make a new one. So I could say create and call it level data, and it'll return a level. So some problems there. First, I did this in the wrong order. So notice that there's a problem here, right? Which is, it says, hey, level is not an input type. So what the heck does that mean? Well, in GraphQL, we have normal types that are used for queries and outputs and for some parameters. And we have input types. And input types are what are used when I have a mutation. So what does the difference between these really look like? Well, let's take a look from our other project here on the difference between some of these. So if I go to my schema in this project, we can see that I have a object that will create a resource. So let's look at our mutations here first off. And let's try to find one that actually uses a object. Here we go. So we have one thing that will create a resource, another one that will update a resource. So that's probably very similar to what we want for level. We probably want to create and update. And instead of our input being a level object like it would be in ours, we're using this thing called a resource input. So what is a resource input? Well, it's basically just a type, but it's called input instead of type. And honestly, that's the only difference. In GraphQL, there's differences internally. For example, input types don't have ID, they're not part of being cached and things like that, but they're defined the exact same way. So if we go to our thing here, we can actually just take our level exactly as it is and make a new input for it called level input. And then we can make this thing use that. And when we're creating a level input, we don't use an ID, but everything else we use, just like before. Right? And now what you'll see is, hey, I defined this works now, I don't have any errors, but look, it's complaining about sheep object here. What do you think the complaint is going to be? Let's take a look. Sheep object is also not an input type. Well, hopefully by now we know what to do. We go to sheep object, copy it. We'll make a sheep input, and we'll make it an input type. And we'll change this to have it be an array of sheep inputs. And if we look down this list here, we're going to see, wait a second, we're starting to get the same thing all down the line. By the way, it looks like we never updated these things to use our new objects. So maybe I'll do that while we're here. For level, we're going to need a single object input. And we're going to need the fence. We're going to need the rabbit hole, dog, and star too. Now, this might seem a little bit odd and redundant when we're doing it this way, but keep in mind that usually when we have GraphQL, our query objects could be extensive because many of the properties on them could be computed or from other databases. So on a level, I might have things like player top score that's fetched by the current player, and is returned when each player fetches this object. We may return their current score in that member function or that member, but we never put that in the create object. So normally there's more difference between the input objects and these base types. So we're a little bit because we have a simple situation here. It's a little bit of overkill, but that's basically why it's not quite as weird as you might think. All right, let's take a look at how we're shaping up here. Fence input, good. All right, and now because rabbit hole is nested, we have to do our hole input too. All right. So now our schema is all done, looks good. We have a new mutation which creates a level. It takes a level input and outputs the completed level. It's kind of a standard way we do creation in GraphQL. Sometimes people just return an ID, but here we probably assume we're going to use that level, so we could do that. And then we have to create the mutations. And this basically works just like before with the query, where for every mutation, we're going to need to define what it is. So our mutation of create level and we're going to have the same format as before. So if we take a peek at how this works in our resolvers, what you can see is the way a mutation works is, let's look at the mutation resolver on this side and the schema declaration on this side. So you see here, when we log in, we're passing a username and a string and returning a string. And what we get here is those parameters are passed in as the second argument. And this one here is going to be the data sources again, just like last time. So we can take this structure and use it to write our resolver. So here our parameters are just the level, because remember in our schema, let's put it over on this side so we can see them both. Oops, didn't mean to do that, sorry. We have new level data as our only thing. So here we have that as our single object as well. And now we can do whatever we want. And normally we just do the same thing. All right, we actually don't have to even await this, but we will just for some debugging purposes. Now if we go to our thing here, we can actually write a create level function. So this should actually be working now. Let's see if it does. We'll fire it up. Didn't get any errors. That's always a good sign. And let's see if we can create a level. We'll take a look at our schema here, so we can have that in the background. Make sure the level is obeying its description. And then we'll define our mutation. Let's just refresh this so we get. And here we have to have our new level data. So we'll notice here that data is not defined because we have to actually define these variables. I don't know if this will actually even let us define it inline. We can try. Maybe we can. That would be convenient. So let's see what happens if we run this right now. So what you'll see here is, hey, we're missing some required fields. So remember, in our schema, we said we require certain things as part of the definition. And that's what these exclamation points are for. So let's go and put in all the required fields. We'll give it a width, 15. Height of 30, amount of time 30, and we also need sheep, which is going to be an array, and for each sheep we need a location for it. And we need an exit. And I think that's it for required stuff, right? Well, let's find out. Field zloc. Oh, of course. All right, so now we can see that this called went through our resolver, called our function here, and now ended up in this create level. And if I look at what is passed in for our new level, it's exactly the data that we gave it. So in our next episode, we'll go through and we'll connect this up to the database to make this. And basically, we create that with the same pattern we used for fetching the data. First, we'll create the basic level object itself, and then, depending on what's inside of it, sheep, dogs, mud puddles, and so on, we'll create all of those objects as well. But that's it for this time. So hope that was informative. Got to see some cool debugging, and we'll talk to you next time.